Okay. The first protocol and the simplest protocol we're going to deal with here for CE to PE here will be RIP. All right, obviously it's the simplest, easiest to do. The configuration is done just like we do BGP. So you're going to say address family IPv4. You can say VRF and then the name of the VRF there. The only little caveat you can run into with RIP is if you're doing RIP in the global configuration, so under router RIP, you're doing some configuration for RIP there, and you do something like passive interface or do the version command there, that config is inherited down by the address family. All right, and I don't know if that was the intention of the command to be inherited by the address family, but it is. Good example is doing passive interface default under the global config, and you think you're only referring to the interfaces that are in the global table, not the interfaces that are in the particular VRFs. So just something to be aware of there. You may also want to be aware of it also for RIP there. Sorry, for EIGRP, because it's going to be configured the same way. The only really advanced feature you can do with RIP here, the only advanced feature you can do is you can configure the PE routers to carry the hop count across, meaning that if they learn to route with a hop count of 5 or 6 or whatever, you can configure them to carry it across. And what they'll do is they will use the MED here, and they will set the MED to whatever the RIP hop count is. Then when they pass it back into RIP on another PE router, that RIP route will go out with the metric for whatever was learned on the other side. Of course, it'll increase by the 2 PE routers, the hop count from the 2 PE routers there. And it's pretty simple to do. You're just going to go under the process here. You're going to under the RIP process. You're going to say redistribute BGP metric, and then you're going to specify transparent. There's going to be a lot of things that we see today that happen automatically. So there's going to be a lot of topics that we're going to see happen automatically. Some things relate to EIGRP and so forth there. And this is one of them. It's pretty simple to do. We don't have to get in there and do anything for BGP for this to occur. All right, so let's go ahead and what we'll do here, let me share out my screen. Share out my secure CRT screen, and we'll do this configuration here. Okay. So this is the design we have. This is the same design that you have in your handout for the class. You have and in this design we used yesterday afternoon. R3 and R6 are the PE routers. They're doing traffic engineering for label distribution. And the VPN we configured was VPN B, and VPN B was for R7 and R8 there. So the first thing we do, because these routers were just loaded with this configuration, show MPLS traffic engineering tunnel, and then make sure my tunnel is up. Oh, my tunnel's down. Let's see here, show IP route, OSPF. If I have reachability, I don't have R6's loopback. Looks like I don't have R6's loopback here. Show run int EU0. This is my tunnel. We named it. So let me go take a quick look and see what's going on with R6 here. Okay, well, that solves, hold on, let me fix this real quick here. Well, that answers that question. It looks like R6 got loaded in R7's configs. As we mentioned, you guys too, make sure you check to see if your correct initial configs were loaded during the lab there. Put this in here, and this should fix it. All right. Real quick. 7 got 7's config. It was good. Okay. Show IP route. Okay, looks like it's all starting to come up now. Let this come up real quick here. And then what we're going to do is we're going to run rep between R3 and R7 and between 6 and R8. Then we're going to offset the hop count, and then we're going to see that the hop count is preserved when it's sent across the MPLS VPN. Let me make sure I can ping down 150.1.56.5. Okay. IP route OSPF. Okay. You can see our tunnel just came up. And let's see if it's up on the other side. It is. Okay, so it's up on both sides. Remember the thing I needed to check too, show IP route, and I need to check the peering address for BGP. 3 is peering with 6, and I need to make sure that's going down the tunnel. If it's not going down the tunnel, we're not going to build a label switch path for it because we don't have LDP in there. If we configured LDP everywhere, then it really wouldn't matter. And a lot of people, that they think that LDP must be configured at the same time when you're doing traffic engineering tunnels, and and a lot of times they're not even really using the traffic engineering tunnels like they think they are. All right. Show IP route 150.1.3.3. Okay, so looks good here. So let's look at 6's config real quick here. Show run. Let's see what we have here. We should have the config left from yesterday, what we did yesterday here, as far as the VRFs go. So there's VRF B. Let me jump up here real quick to the top. So there's my route descriptor. RD there. My route target import and export is 3636. Doesn't really matter what you use. Unless it's in the lab and they tell you to use something particular. All right. I am peering multi-protocol BGP. There's my VRF, and I'm redistributing connected into that VRF there. That's that. This is the static route that was supposed to be on 7 there. Take that off. Okay, so what I can do is I can see if I can ping between connected interfaces within the VRF there. So ping VRF B 10.1.37.3, and so I can ping the directly connected. Even though you may not have a scenario where it asks you, in the scenario, it may not ask you to ensure that you could ping, directly connected on the PEs within the VRFs. It's really good to do in your initial testing to go ahead and just redistribute the connected in. So redistribute those connected interfaces in that VRF, so that the P routers, the other PE routers see those, and then try to ping there. Because if you run into some configuration problem later on, you can still test to ensure that your MPLS VPNs are working properly, just by pinging those directly connected there. if I have to rely on a routing protocol, there may be a problem with R7 or R8 or something wrong with the route distribution or so forth there. So this makes it a lot simpler to deal with. Okay, so now that we know this still works, let's go ahead, and what we'll do is we will configure RIP here. Let me put this on here just in case. I hate to make that much screen scroll by for you. Just want to make sure the config was there. And okay, I just like to do a lot of verification. There's when you get into some really complicated configs, especially when you get into some things like layers that have to do with carrier supporting carrier, you really want to find out problems early. All right, and if you're in the CCA lab and you think you don't have time to do this basic testing, you really, the way I look at it, you really don't need to be in the lab. That's why, a lot of people's strategy is that they'll say you could finish early, like about 2 o'clock in the afternoon or 1 o'clock in the afternoon. I really take my time and do a lot of verification as I build, so that my goal is to finish an hour and a half early, which is plenty of time, because it gives me a 15-minute break, take a quick break, go get a drink, and then, I have plenty of time to, go back and do more in-depth verification and rereading of the questions. But I've built everything and tested it as I built, so I don't run into this, major problems towards the end. Okay, so let's go ahead and enable RIP. So router RIP, this is on the CE device, version 2, no auto. And the IP addresses on the CE device are all within the 10 network. So we're going to say network 10.0.0.0, do show IP int brief, and include 10. Okay, so there's the loop back here. And what we'll do is we'll do an offset list just so we can verify that the metric is being sent across the MPLS VPN transparently here when we get into the redistribution. What we'll do is, to test this, we'll do an offset list for the loopback so that the Ethernet LAN here should go across the Ethernet, the 10.1.37.0 network should go across with just a hop count of 1. Now what we'll do is we'll offset that loopback there. Let's make an access list real quick. Access list 1, permit. Let me get out from under the router config. 10.1.7.7. All right, and now let's go to RIP, router RIP. Offset list. If you don't specify an offset list number here, of course you can just say 0 for no access list. We'll use access list 1, and then it's going to ask us outbound, and then it's going to ask us what the offset is. We'll make it 10, just so it sticks out. Or we could make it 8, so it ends up as 10 once it gets across. But we'll just make it 10 here. All right. So now what we'll do, let's go to 3. Let's configure RIP on 3 here, and go under the address family configuration for it here. And network 10.0.0.0, version 2, no auto. Do show IP route BRFB. Should receive the loopback from R7 there. BRFB, network 10, version 2, no auto summarization. There it is. Okay, so it's in there. And we see it in here with a hop count of 11. So we offset it with 10, we're going to take it in, and it's going to be 11 here. All right. So the next simplest step here, I'll just enable RIP here on R8 here. So router RIP version 2, no auto, network 10.0.0.0, and go back to 6. Address family, IPv4, VRF, B, and version 2, no auto summary, and network 10.0 to show IP route, VRF-B. I should be getting the loopback here. So I'm getting the loopback from R8. So this tells me that my CE to PE protocol is working, everything's okay. Now I'm going to go do the redistribution, redistribute RIP into BGP, and redistribute BGP back into RIP. So I'm already under the RIP configuration, so I can say redistribute BGP, the AS number 200, metric, and it gives me the option for transparent. Remember those basic rules for redistribution. Okay, basic rules for redistribution. If you redistribute, a protocol like into RIP, you're going to need to specify a metric. So don't let those little type of rules create problems for you there. And now I'm going to go under router BGP 200. When I'm working back between RIP and BGP, I just keep doing the up arrow till I find that address family config command, because it's the same thing here, except for that it can get confused with the IPv6 address family command. Okay. And I'm going to say redistribute RIP. You don't need to put a metric on when you're passing routes into BGP. Anyways, for us, what's going to happen is the hop count will become the MED, and then the MED is sent across over to R3, and then R3 takes that MED and puts it as the RIP hop count. All right, and let's go over to 3 here. So we have the loopback of R8 now, okay, because we've done the redistribution on that one side. Now we're going to do the redistribution on the other side here. So redistribute BGP 200 metric transparent, and router BGP 200. And redistribute RIP. All right. So now what we want to see, we want to go all the way over to router 8, show IP route RIP, and see what we see here. And we can see that the loopback from R7 has a hop count of 12. We offset it with 10. It went to the first PE router. It got 11. It goes out through here, goes all the way over to R8 here, and now it's got a hop count of 12. So that's exactly what we expected here. So it's the MED value here. So the MED value here is being used to carry the hop count. All right, and as you can imagine, especially like in this design, it doesn't matter too much. But once we get into designs where the two, which was what we're going to have today, is once we get into designs where R7 and R8 have backdoor links with each other, then you can get into issues with suboptimal routing there. Show IP, BGP, VPN, all. Let me get on to the right router here. 6. Show IP, BGP, VPN4. 10.1. 7.7. Let's look at the route here. The origin incomplete, metric 11 there. A lot of this stuff we'll actually be able to see when we get into when we use like OSPF across the MPLS VPN, or use EIGRP across EIGRP as our P to C protocol. So it's traversing our MPLS VPN basically through BGP. A lot of this information will be carried within BGP, but a lot of it's really encryptic as far as trying to dissect what is what here. Okay, so that configuration's pretty straightforward. We can just take a look at it real quick here. Let's just take a look at our full config. Let's get down to RIP here. And we can see here, address family for BRF, we're redistributing, BGP, metric is transparent, and then the network number, and then the version, and then the exit address family. Then after that, that's pretty much it. And then, of course, under the VRF for BGP here, we're going to specify redistribute RIP. We could take off the redistribute connected now. We just had that in there for our initial testing of the MPLS VPN from site to site there. All right. Okay, so RIP, and that's pretty much all you can do. There's really not a lot you can do there. There's not a lot of fancy things you can do with RIP, other than pretty much what you've seen here. Anything else that you would do would be like if you did authentication, that would be pretty standard. That of course would go under the VRF config there. So that kind of stuff is going to carry over from your state, your CEDARs, your CCNP learning, or your routing and switching if you already did the routing and switching there. Okay. All right. So RIP, easiest protocol that we're going to deal with today. The rest of them, it's all downhill from here. Just kidding. But yeah, this is the one of the easier protocols, and that's the only thing you'd want to be aware of, is that you can transparently send the metric across, and it really goes into dealing with suboptimal routing that you could possibly have. You could have, one thing we could have done is we could have redistributed the routes in from BGP and then didn't set the metric to 5 or 6 rather than just say metric transparent. But obviously, in a design that's not very static or has a lot of RIP routes with different metrics, that really won't work to do that. Okay. So that was RIP. Pretty straightforward, pretty easy, not a lot to do. More than likely, the harder protocols that you would deal with, like I said, will be more than likely will be OSPF, and possibly using BGP as the PE to C routing protocol, which is one of the things we will do today. So we'll use BGP as opposed to RIP between R7 and R8 there. Okay. For EIGRP, if we're using EIGRP as our PE to CE protocol, the configuration will be, the logic of the configuration is the same. So we're going to specify router, EIGRP, the AS, then we're going to specify the address family. Under the address family, we can alter the AS number. Okay, so we can alter the AS number there if for whatever reason we need to. Now, by having different AS numbers, now this is what we're going to see, the same theme between EIGRP and OSPF. With EIGRP, if the AS numbers are different on each side, okay, if the AS numbers are different on each side on the PE routers, so if I'm using AS 100 on one PE and I'm using AS 200 on another PE, those routes will be learned across as external. It's like, because they're coming from a different EIGRP process. So the internal routes will come across as external, the externals will come across as external. If the AS number is the same on each side, so if the PE routers, when they're communicating with the CE routers, if they have the same AS, the internal routes will remain internal. Even though we have to redistribute them into BGP and then they go across and out of BGP back into EIGRP, the routes will remain internal there. The information relating to the EIGRP AS, some additional values like the EIGRP metrics, the route type, internal, external, all that is carried within BGP. Okay, so it uses a combination of the MEDs and a combination of extended communities to carry all that information. Now, once again, it's very encryptic when you do a show. You can see a lot of the output when you do a show, IP, BGP, VPNV4, VRF, the VRF name, and then the IP address of the route. You will see some information there, but not very likely do you need to go in there and look at that information. All right, but it is there, and it is carried by EIGRP. And this is automatically done. We don't need to do anything for this to occur. This is the way the routes will show up, via internal or external, here. So let's go ahead and let's switch over our routing protocol. And what we will do first, real quick, is we will set the PEC protocol as EIGRP. Then we will also use the same AS number. And what we want to see is, though, even though we're doing route redistribution, routes are getting passed into BGP and then back out to EIGRP, we want to see that they come back in as internal routes. Okay, so how we'll do this testing? We'll create additional loopbacks on R7 and R8. We'll just create an additional loopback. One of the loopbacks we'll use a network statement for in EIGRP. The other one we'll do redistribute connected, so that we do have some internal and external routes. Let me flip to, I'm going to jump ahead real quick, and let's look at the diagram here. Don't worry about what this relates to just yet. But so what we're going to do is we're going to run EIGRP AS100 here between R3, R7, and R6 and R8 here. And then what we'll do is create additional loopbacks on, and then we're going to see how those are learned across. For our scenario, we don't have this link up yet, but we will be bringing up a backdoor link. All right. As a side note, when you're doing like practice labs, or even in the real world, sometimes backdoor links aren't your friend. They just can create these, what I call a backdoor link, because it is essentially, it's tying two VPN sites together. A lot of times, customers will have this stuff for backup purposes. Backup purposes in case their MPLS VPN site goes down, or MPLS VPN connectivity goes down. Okay, so that's what we're going to have here. Yes, in our case, someone asked if R7 and R8 are the CEs. That's correct. R6 and R3, it's exact same with RIP. It's the exact same configuration. Get tongue-tied there. It's the exact same configuration as RIP, except that we're going to switch it. We're going to remove it. It's the same design. All right, so let me share out my window here. This will be pretty straightforward. No router rip. Do show run. Begin. Okay, when I did that, it removed the redistribution of RIP out of there, into BGP. I'm going to go ahead and remove the, excuse me, I'm going to remove the connected also. And no redistribute connected. All right, and no router RIP here. Okay. And let's go under router BGP 200. And no redistribute connected. Okay. First things first, what we'll do is we'll get the PE to CE protocol up and running. So we'll get the PE to CE protocol up and running. Make sure that works. Once that works on R6 and R3, then what I will do is I will go ahead and pass those routes into multi-protocol BGP. Okay, so no router RIP. Let's create a new loopback on here. So interface loopback 1, IP address. All right, so now we're going to do router EIGRP 100. Let's see here. This is a new switch. All right, let's do it on the other router real quick. Hang on a split second here. On the next break, what I'll do is let me go to the other switch real quick here. I got the right version here. No, I don't have the right version here. Apologize about that. I don't know why. It has the image. This is a problem if you ever upgrade these switches. It has the image in Flash, but it boots this image here. Let me just remove this one and reboot it, and we'll do the rest of the config first here. Let me see here. CD here. I'm going to remove this one out. Okay. Okay, let me save this config here and let this reload. Oh, it boots up to the new image. Let me go over here real quick and let me do a dir on the flash. Make sure it doesn't have it in. No, it doesn't have it in there. Oh, it does have an image actually. It's just named Flash. Looks like I'll just be able to reboot these real quick. Okay. Let me copy this over here real quick here. while that's happening here, let me go ahead and we'll go ahead and do the configuration on our 3 and our 6 here. So it's going to be router EIGRP 100, and we're going to say address family IPv4 VRFB. Okay, now we'll do our network statements. We'll do our we'll do our network statements. Anything we would normally do down here, we can also change. We can also change the autonomous system, as long as you don't try to spell it with an M. Right there, if we wanted to use, a different autonomous system number there. Okay, network 10.0.0.0. No auto. And what we will do is redistribute BGP 200, and we need to specify a metric here. So people always ask, well, what metric do you use? Just choose, something like off the Ethernet interface. Really doesn't matter unless you're trying to avoid some sort of suboptimal routing. Reliability, load, and then MTU. And then router BGP 200, the same address family command here, redistribute EIGRP 100. Okay, and let's go over to 6. And router EIGRP 100, address family IPv4 VRFB, network 10.0.0.0, no auto summary, redistribute BGP 200, metric, $150. And then router BGP 200. And redistribute EIGRP 100. All right. Just as a quick side note, we're waiting for that router to reboot. You can set your history size of your the up arrow to something really large if you'd like to use it a lot. I think it defaults to like 12 or 10. I think it's 12. When you hit the up arrow, you can set it to 256. I personally like working on a Linux box where I can really go back and view my whole history. Any command I've typed, the last 1,000 commands or whatever it is. All right, let's see if that router it's done copying. Sure. Okay, so let me remove this one. You know what the interesting thing is about this? I can figure out which support engineer probably did this based on the fact that they misspelled flash. I have a really good idea who was the support engineer that installed this for us. All right. Let me delete this here. Ryan said, so do I. Well, I have my own moments with that kind of stuff too, but I usually catch them too. Let me save our configuration here. Okay, reboot. All right, let's see if this router's back up. Advanced IP service is good. All right, so router EIGRP 100 and network 10.0.0.0. No auto. And then what we want to do too is we want to bring in we want to bring in that additional loopback that we're going to make here. IP address 7.7.7.7. Okay, and let's do a route map connected to EIGRP, match interface LO1, the router EIGRP 100, redistribute, connected, route map, and it's connected to EIGRP. Oh, let me put in a metric there. Okay. Now what I can do is I can go over to the closest CE router, and see if, which is R3, sorry, not CE router, PE router that's closest to this CE router, and see if I see those EIGRP routes. Don't see anything yet. I don't have a neighbor here. And this shouldn't be relying on the other switch to reboot. 10.1.37.7. All right, can't ping and directly connected. Go back here real quick. Show run. The IP address is on the interface. Ping 10.1.37.3. Okay, there it goes. Oh, I was doing a ping outside of the VRF there, which is easy to do. VRFB. All right. And still haven't formed a neighbor on that VRF. Look at our config real quick. Yeah, that's a good point. As a side note, you will catch yourself every now and then doing that, pinging, trace routing, or trying to telnet. When you do a telnet, you do it at the end. You say telnet the IP address front slash, and then you specify the VRF there. Trace route too. You want to specify trace route and specify the VRF there. I mean, it's easy to just ping, or just trace route, or just telnet there. Make sure you're doing it within the VRF. Okay. Router EIGRP 100, no redistribute EIGRP 100. That must have been in there by default. Network statement 10. No redistribute. Let me look at this. Show run. Again, router EIGRP. I got the neighbor statement there in the middle. Over here real quick. Get his config real quick here. So there's the second loopback. See if I didn't leave the network statement off or something. No, there's a network. Redistribute connected. I can ping across. Look at 3 again. Looks like the issue's here with 3 real quick here. I'm going to take this out. I don't know. Let me specify it here. All right, there it goes there. Thought I had that in there. I think I showed you the command, but I didn't put the autonomous system in there. There we go. I got kind of a little thrown off of the order of operations when I got those routers switches that didn't have the right image on them there. Show IP route, BRFB. Okay. So this is working as expected here. So this is working as expected there. And let's go to 6. Router EIGRP 100. So this is the exact config. What we're doing here is the exact config of what we'll have over on the other side. Said 100, but typed 10. Network 10.0.0.0 and no auto summary and redistribute BGP 200 metric. All right. Show IP BGP VPN4 all. Don't have any routes. I'm not learning any prefixes here. So I don't have any prefixes learned. So that shows me that the redistribution into BGP isn't working yet here. Let me make sure it's router BGP 200, address family, IPv4, VRFB, and redistribute EIGRP 100. Go to 3, show IP BGP VPN4 all summary. So I have one route being learned across. Let me make sure redistribution is occurring here. Distribute EIGRP 100. All right. There it is. So it really didn't take until, because I typed the autonomous system command and showed you guys, I didn't press enter on it when I put 100 in there. I didn't put 100 in and press enter there. Okay. Show IP route BRFB. Okay, so we have these routes learned across here. Now let's go finally here. All right. And we need to do make sure this was saved for the, and it is. The router EIGRP 100 and redistribute connected route map. The name of our route map here. Metric. $1,500 here. Okay. The only reason we brought in those extra loopbacks just so we can see the internal routes and the external routes, how they're learned across through EIGRP. show IP route EIGRP. So we can see here that that loopback that was passed in through external, so is redistributed in, which was an external route. That remains external. The loopback that was done via the network statement on the remote router remains as an internal EIGRP route. So this worked as expected. So this worked as expected here. The only difference we would run into, the only possible difference we could run into is if we switch over the, if we use different AS numbers. If we did a different AS number between 3 and 7 or between 8 and 6, everything is going to show up as external. Right, but if you keep the AS numbers the same, they will show up normally. Okay, you want to remember these kind of things in case you come up with some, some weird requirement where, you are making them external so that they prefer other paths, maybe some backdoor path there, so that they don't prefer, so that they do not prefer the MPLS VPN path there. All right, let's do something real quick. We're going to bring up, because we're going to use this a little bit later here. We're going to bring up a link between R7 and R8. Actually, let's just do this. No switch port IP address 10.1.78.7. Okay, so I'm just going to bring up that link there, because we're going to use this for a lot of more topics there. And we're going to use it for OSPF and so forth here. All right, let's see. They should become EIGRP neighbors, and they do. So you can see here we do end up with theoretically suboptimal routing, because you can see to get to the 37 network, we go across that quote-unquote backdoor link, the link between that we just brought up between R7 and R8, and they also go across the MPLS VPN. The cost does not change as it goes across, and that's essentially the quote-unquote, not necessarily the issue you see here, but this cost does not change when it's sent across the MPLS VPN here. This cost remains the same. And that information, show IP, BGP, VPN4, all. Look at a route in question. 10.1.1, sorry, that's 7.7. And this is all the additional information here. This is all the additional information about the EIGRP here. And this is, as you can see, this is the MTU. And this information is picked up automatically and sent across for us here. In one or two of the Cisco press books, I think they explain they explain the details of this, because it is pretty encryptic to say the least there. All right, let's look at the route. So IP route PRFB. So there's what we have. There's the MTU, the bandwidth, the delay, the loading, the reliability here. let's look at it from, well, look at it in BGP here. So there's not really a lot that we're going to really want to look at, but this is telling you information like what is the remote, what is the remote router ID. It's telling you the AS number of the remote device. See AS number 100 here. So there's some additional information here, but it's really not too much of a concern to us. We're not going to get in here and troubleshoot this kind of stuff here. All right. What we can do, if we look at it, we also we set the metric on our own, but yet it took whatever metric it was carried across. Okay. This right here, we're going to go into some. We'll talk about this cost, the cost pre-best path. We're going to go into some issues with suboptimal routing in MPLS VPNs in the next slide, actually after the next break, and we'll look at where this is used. Because essentially what eIGRP is going to do for us, it's going to do some automatic checking and comparing of the eIGRP routes and the IBGP routes, the multi-protocol IBGP routes, and it'll compare them side by side as if they had the same administrative distance, basically. So it'll go in there and compare the metric to ensure that it chooses the one with the best metric, not always relying on eIGRP, because it has a better administrative distance. Just for simplicity's sake, let's go here, router eIGRP, not simplicity's sake, but just for, let's change the distribute BGP 200 metric. That's a big metric right there. Go. And it's pretty much not mattering. It's taking the metric that is being learned across from through BGP. So even though we put whatever metric we wanted there, it didn't matter in this case. Clear. Type here. IP route VRF star VRF. Yeah, it's not changing here. It's actually picking up the metric and using whatever metric it picked up there for that route, and it's passing that across. All right. And what you see with it, as you can see though, sometimes this may not be ideal behavior because it's picking up and passing it across unchanged, so that theoretically, from a design perspective, R8 should go through R7 to reach the network between R7 and R3, not go across the MPLS VPN. All right. Okay. So, but this is done automatically for us. We don't need to do anything here. Someone brought up a question. They said the question was, let me do something real quick here. The question that was brought up said, why is it saying it's learned 7 through R8? Shouldn't it be through R3? It really depends on the metrics when it learns it here. Let's look at, you could get into, well, I guess this would be one reason you may want to get in and start looking at all this. You could get in here and try to determine what metric we have here. So what this metric is here. that it's using, why it's using this over the other one there. Well, just to let you know, for one thing, R3's interface that it's learning the loop back across is 10 meg. The interface, the backdoor link between 7 and 8 is 100 meg, and the link between 8 and 6 is 100 meg also. So it's preferring the 200 meg links over the 110 meg link. So that's why it's preferring it there. Yeah, because we brought up the backdoor link there. Commonly, your backdoor link though is not. But commonly, your backdoor link is not more preferred over your MPLS VPN connection there. Okay, so let's alter that here. Interface FA0/15. Oops. I'm going to go to the routers at the backdoor link. Delay, and let's set the delay to some really high value. Make it one less. And let's go to 8 here. And delay. All right. Let's clear the neighbor relationship. All right. Let that come back, and then we'll see what the best path is here. Back to 6, and let's look at it. Now it's preferring this here. So now it's preferring this route here. Let's go to 8, show IP route. It's from 6 here. All right. So normally your backdoor link will be, your backdoor link will be less, it's backdoor. It's not primary there. It's used as a backup. Now, if these, if the MPLS VPN goes down, they'll of course route across their backdoor link there. Okay. Let me switch back to the whiteboard here. All right, so we saw that the EdgeRP routes continued to be learned as internal as long as we had the same AS number. We didn't spend the time just to change the AS numbers, but just remember though, if you change the AS numbers, they will all be learned as external, okay? Because they understand they're being redistributed into a whole new process. That process ID, the autonomous system for EIGRP was carried across. When we actually get into OSPF, we'll have the same types of issues with OSPF. And then OSPF we get a little bit more complicated because we not only have to deal with the process IDs, and they check the process IDs between PEs, but they'll also check something called the domain ID. All right, and it's going to pretty much do the same type of thing. It's going to affect how the routes are learned here. So we can see here, even though we put that metric as 11111, it wasn't really high. The metric was not something outrageous. When we went over to R8 and did a show IP route on 10.1.7.7, which was a loopback that was running from 6, which was across the MPLS VPNs, that loopback still had a normal, a pretty much normal metric. It was like 40,000. If it was all, if it took the metric from your distribution, it would have been like 900,000. It would have been some really high number. Okay. Let's take a break here real quick. Let's take a break before we go into um, a feature called Site of Origin, and we'll talk a little bit about cost community, but there's nothing really needed to be done with this here. So let's take a break. Let's start back at let's start back in 10 minutes at 25 minutes after the hour, and then we'll continue on. All right. Let's look at, real quick, I wanted to mention the BGP cost community. Basically, what it's allowing us to do, it's allowing the router, the PE routers, to compare. I mean, let's step back for a second without the cost community. Let's look at a network diagram, and let's see what happens normally for routes with EIGRP. Let me clear this off here. So let's say we have a route, and the route comes across from BB1. Okay, so this route comes across from BB1 here, and that route is learned by R6. R6 takes it, sends it to R8 here. R6 also sends it across the MPLS VPN over to R3. R8 gets it. It's got a backdoor link, sends it to 7 here. R7 gets it and then sends it down to 3. Now, the problem we would have if we didn't have support for this feature, let's look at it without this feature here. The problem we run into is that when R3 gets the route, he gets it through BGP, correct? IBGP, and R3 gets it through EIGRP from R7. So R7 sends it across as EIGRP, R6 sends it across as IBGP. So which route is R3 going to prefer? Well, obviously it's going to prefer the one with the lower administrative distance. So the lower administrative distance, well, what would happen is R3 would route to R7 and then across to R8 and then to R6 to reach BB1. It would route across the top. No matter what the speed of this link was here, because it doesn't matter if this link up here even was a 56K link. Because the problem we run into is that IBGP has a higher administrative distance than EIGRP. So it doesn't matter what the speed of this link is here. So what you have is, you have a situation where, okay, if I'm using MPLS VPNs, I can't have a backdoor link with using EIGRP here. So I can't have a backdoor link here because of this issue. So what's been added in, and this is done automatically, is something called a cost community. And what the cost community does, it allows the comparison of an IBGP route to an EIGRP route based upon the metric. So irrespective of the administrative distance of the two protocols. So it's going to look at the metric of the two routes to determine which one it will use. And that's done for you, automatically here. So there's nothing happening here. But it can get kind of confusing if you don't know this feature exists, because you don't understand why 3 goes across the MPLS VPN when it has a perfectly good EIGRP route. Why would it choose IBGP when it has, the EIGRP route? And it's because of this behavior. And this is done automatically behind the scenes for you. And it's actually been around. It's been around a while. So you'll see it in all the iOSs you're exposed to in the lab here. So just understand that this behavior here is, these kind of features we're going over today, these aren't features you use every day, but you want to be aware of how things work. You want to know the possibilities and why things do the things they do, so that when you get into the CCA lab, no matter what question they ask you here, you will be able to come up with a solution, or at least understand what's going on. Someone brought up the question. They said, so need to configure the delay. It doesn't matter what the EIGRP metric is if we don't have the cost community, because it'll prefer IBGP. But if we're using iOS that support the cost community feature, which is what we have, the metric will be sent across. and then we don't need to do too much delay here. We may do a little bit of delay. You may want some routing to the backdoor link, some possibly, but more than likely you don't. You just want to get in here, and you just want to get in here, probably offset the delay so that you always choose the path across the MPLS VPNs, so that you don't choose your backdoor link. All right, and this is why when we change the metric on the backdoor link, the route installed in the routing table on the PE routers were BGP routes. So the EIGRP route was gone, and now it was a BGP route. So we saw that earlier. Before, R6 had an EIGRP route to R7 to get to R8 to get to R7's loopback. Now, once we altered the delay on the link there, the metric changed, so it had the IBGP route, and it was able to compare the two. So all these rules we see about, these standard, about dealing with administrative distance and so forth with routing protocols, it kind of gets thrown out the window when you start doing, when we start to do MPLS VPNs, because we need to have some of this type of behavior. All right. We did, somebody said, is there a good command to see this? When we did the show IP BGP, we had that information there. So that information was here. Let's look at it again real quick. Let's go to 6. So you can see here this route is learned via, this is what we said earlier, it was learned via EIGRP, but now it's learned via BGP with a distance of 200. So it threw away it essentially said, I don't care what your administrative distance is, I'll compare EIGRP and IBGP together here. And let's look at the route here. So this is the information that we have here. These values will essentially break down. These values are going to essentially break down what this 0x8800 are going to, or 0x8801 will break down what we have here. This is with the 1. This is telling us this is the EIGRP autonomous system. This is the delay. On 2, this is the this information here is it's kind of hard to look at because it's kind of combined together, but it's more of the metric, the reliability, the bandwidth, and so forth there. Again, 03 is also more of the metric information. You can see the MTU clearly here. So this information is, available to us here. Okay. This is the this cost here, this cost community. This is telling us here what is the route an internal or external EIGRP route. If it's an internal EIGRP route, it has a value of 129. If it's an external EIGRP, if it is an internal EIGRP, it has a value of 128. If it's an external, it has a value of 129. So on this cost value here. Here is the composite metric. So there's the composite metric that we see on the route right there. See it? So there's the composite metric that is being passed across. These are just all the individual values here. So this is all, these are all the individual values here. And this is the value saying it's an internal EIGRP route, and this is the metric there. So the question said, so the cost community enhancement removes administrative distance from the selection criteria. That is correct. We're not going to get involved in the selection criteria, based upon the administrative distance, because we know it is an IBGP route. So we know it is an IGP route here. Sorry, an IBGP route here. It uses 128 and 129, 129 for external, so that it knows it's an external route. So if you have a case where it's an external or internal, and you're trying to compare which one to use, well, obviously, if the one I learned across the MPLS VPN was external, but it has a better metric than the internal EIGP route I'm learning directly from R8, well, I don't want to use the one across the MPLS VPN just based on the metric, because it is external. So there's two factors that come into play. This route is going to be treated as internal. So essentially what it's going to do is going to say, this is an IGP route. Sorry. This is an IBGP route, and I'm going to treat the administrative distance as 90, like EIGRP. And what I'm going to do now is any other routes that I have for this loop back here, so any other routes that I have for this loop back here, I'm going to compare it based on the metric right there. This question here, it says, so in theory, if we shut down the link from R3 to R1, we will learn the route directly from R7, and it should have a higher metric. That is correct. We could clear IP, BGP, star, clear all the BGP here. Clear IP, route, VRF, B, star. No, it came back too quick. Let me do this. Let me just shut down the interface real quick. Shut down the interface, so the MPLS VPN essentially broke. Now we should route across R6 should go to R8. So let's see if that route shows back up here. And it's gonna take a second to propagate out. Let's see what 8 shows real quick. Doesn't have the network in the table. Clear IP, EIGRP neighbor. Let me just clear the process. Do I have through EIGRP? I don't have any routes yet. Let it come up real quick here. Clear IP, EIGRP neighbors. Have neighbors. Don't have any routes though. I have 6's information. I don't have anything from 7 across that link. 7 looks okay across that link. IP route, what do I have here? Static default, that was left on from earlier, which really doesn't make a difference here. Let me clear it on 7 real quick too. Bounce these neighbors here. Back to 8. It's kind of odd. I should at least get routes between R7 and R8, which like I was doing earlier. When you run into kind of obscure problems like this, the only change we made was we set the delay to really high on that link, but we're not getting any routes across. So, you know, once again, what we'll do here is let's look at the config. Show run, begin router EIGRP. Network 10. That's the link across. No auto summary. Keep this out while I'm here. Twice there. Okay. Anything across that link. Let's go and take that delay off that link real quick. Try to get back to a normal configuration here. Even though theoretically it shouldn't make a difference at all, right? But we know how things really work against how things don't really work there. Okay, clear the neighbors real quick. Show IP route EIGRP. So he's getting the routes across. And he's not getting the routes. You don't even have them here. So step 2 would be show run pipe begin, clear the whole just blow away the whole process. Blow this whole thing away here. Doesn't have them in the let me shut down this link to 6 real quick. Trying to isolate this here. Did I remove it from the right interface? No, I didn't remove it from the right. I removed it from the wrong one. I think I typed too quick. Let's see if it comes back real quick here. There it goes. Okay. As a side note, don't use a delay that big. All right. Okay. So I cleared the delay. Obviously, I typed in the wrong interface there. All right. Let me bring up the other link now. You're probably sitting there going, why can't I make a delay that big? And I'm going, I don't care. I don't really care why. I'm just not going to ever make delay the maximum again. I'm going to choose something lower and leave it at that. You eventually get tired of chasing down stupid problems like that. All right. Okay, so let's go back to 6. Show IP route DFB. Okay. So now it's learned. Now what we'll do is the MPLS VPN is down. We are learning the routes across the backdoor link. So we should have full reachability. I don't know if I should ping. I should just leave it at, I have the routes, it must work, huh? No, I'll ping across. Try to induce some extra troubleshooting into the class by doing it live. Brian and I joked about with the new software, we could actually just run flash recordings of us working on the routers. But then you would miss all the beautiful, not all the little mistakes we make. All right. But you'll see that I probably make a little bit more mistakes than Brian. But I'm also pretty good at finding my mistakes. All right, that's one of the things you'll find that's the key to networking. You can make mistakes, just make sure you can find your mistakes and recover from them before anybody else sees their mistakes. Unfortunately, you guys see all my mistakes. All right. But I don't know, just as a side note, while we're waiting for this to come up, we're waiting for our traffic engineering tunnels to come back up. I don't know anybody who doesn't make mistakes. You know, being able to make little mistakes and recover from them quickly is key. Most people who have problems passing the lab make little mistakes and can't recover from them. I should get like a CCIE in troubleshooting and creating problems at the same time. All right, our tunnel's down. We're not up yet. Ping 150.1.3.3 source LO0. So we OSPF looks like it's just now starting to converge here. There we go. Okay, took a second for OSPF to converge. Sure, and now we should see. Let's look at the route again. Before the route was EIGRP. Let's look at it real quick. We had these routes via EIGRP. So there is the composite metric. And we'll see that this is external here, and this composite metric here for this particular loopback will be lower than our composite metric. So do a show IP route, and let's look at that loopback, the one that's external. So we're using the EIGRP route. Okay, and let's look at it in BGP. The composite metric that we have is 261,000. So let's look at it in BGP. Here. We can see that it is an external EIGRP route, and its metric is 261,376. This one is exactly the same, but it only preferred the one originated in EIGRP here, even though they were even though they're the same here. It's not going to load balance on the two. It won't load balance on the two. It's going to prefer the one that is in the protocol natively. Meaning if it gets down to it, if it gets down to where they're both the same, they're both external, and they both have the same metric, it's going to fall over to the tiebreaker. What it's going to fall over to, it's going to fall over to the real administrative distance to find out which one to use. Because theoretically, you wouldn't want to do too much load balancing there. Now, what I can do is I can go alter it slightly. I could change the bandwidth. Okay. Actually, yeah, well, we could change the delay, just not change it so big. Let's say 100. And let's look at it on 6. It hasn't updated yet, but you'll see the metric has changed. Okay, and let's see what if it'll eventually flip over here. 28.4, 28.1. So it is lower via BGP. Okay, now it flipped over to the BGP route. See it? So now it says known via BGP. So it's flipped over there. Right, so we were able to look at it. And the biggest thing you're going to look at if you want to get in and start doing this stuff, really what you're looking at is it internal or external EIGRP. 128 is internal, 129 is external, and then what is the composite metric? You really don't need to get into this other stuff here. You may want to know this 8801, and you want to know that that is the AS number. So, if in case, your routes are all showing up as external, that means it's coming from a different AS there. All right. Actually, when I put that slide together, I didn't think I'd spend that much time on it, but I think it's kind of interesting to go over this. I think I'm probably the first person to ever actually test it out, or actually try to manipulate it, besides the person who requested the feature from Cisco. All right, it's one of those features. It's one of those features. There's a little bit of documentation about this in the MPLS configuration on Cisco iOS book. But once again, it's one of those types of information. Really good book, but it gives you everything, and it's like, well, everything's cool to know, but what's really important? And like I said, the cost, pre-best path values are what you're looking at, what you really want to know. You want to know you want to know what the composite metric is it internal or external, and then you may even want to know the AS number that it's learned from, in the BGP route. All the other stuff, I mean, you're really not going to get in there and worry about like MTU or so forth there. Okay, so that should help us give us a clear understanding. This is advertised, of course, to IBGP peers and Confederation peers, but it doesn't. It will not go, of course. It will not go if you're doing inter-AS VPNs, MPLS VPNs. This is not going to get sent across. Okay. Another topic with EIGRP is something called site of origin. And we're going to see this topic again when we get into BGP. I'm going to explain it in EIGRP and what it relates to in EIGRP. What potential problem we're trying to solve with the site of origin. So the potential problem that we are going to try to solve with the site of origin, let's say we have a route, again coming from BB1 over towards R6. R6 gets that route, sends it down to R8, also sends it across the MPLS VPN to R3. Now, so what we have here, R3 sends it to BB3, and R3, of course, sends it to R7, and at the same time, R8 was trying to send it over towards R7. So you're going to see there's going to be, depending on how quickly the route was learned across the MPLS VPN, R3 may get it first from R7 or may get across the MPLS VPN there. Now, not really a big deal. The way it's, excuse me, the way it's working now, we're preferring the the path with the best cost here. So everything's working fine. The problem we can potentially run into, so the problem that we can potentially run into is we could potentially have a situation where the route is learned from BB1, like what we have. Now, let's just say for sake here, the route goes down. So this route goes down here in EIGRP. When the route goes down, 6 notifies 3. 6 also notifies 8. 6 notifies 3. And 3 notifies 7. And let's just say 8 hasn't notified 3 yet. So 8 hasn't notified 3 yet. So what you have is 7 has a route to this route that's now down through 8. So because 8 and 7 haven't notified each other yet. So now what happens is, what's going to happen is 7 is going to tell 3 about the route through 8. So 7 is going to tell the route, tell 3 about the route, and then 3 is going to tell 6, and then it's going to keep looping around essentially. You're going to have this potential problem of the routes just keep looping around. So the route's going to loop between 3, 6, 7, 8, 3, 6, 7, 8, keep looping around. It will eventually time out, right? So if the route keeps looping around, what happens as the route loops around? Route's hop count increases. EIGRP has a limit on the number of hop counts. I believe it defaults to 100. You can alter that, of course, make it up to like 255 or 254. So it's going to eventually just keep flipping around until the metric gets so, sorry, not the metric, but the hop count gets so big that it gets cleaned out of EIGRP. So we may want to have a situation where we may want to have a design where a route that's learned from, a route that's learned from a VPN site, let's say like BB1, and it's sent in down to another VPN site that has a backdoor link, we may want to have a situation where we do not accept. So we do not accept